Have you ever wondered what images of Earth would look like if the Hubble telescope were pointing directly at us? This is a question many have, and the answer may surprise you. Hubble operators often receive this question, and their FAQ section addresses this curiosity clearly and directly. But what actually happens when we try to observe our own planet with one of the most powerful instruments ever created? Contrary to popular belief, the challenge isn't that Earth is excessively bright. As Phil Platte of Bad Astronomy pointed out, Hubble does indeed direct its gaze toward Earth on several occasions, especially to calibrate its instruments. The real obstacle, however, lies in the telescope's slowness. Let's explore this further. Imagine we want to capture an image of an ordinary table. The photons reflecting off the table must pass through Earth's entire atmosphere, which can cause distortions for telescopes on the surface. However, for a telescope in space, this issue isn't as critical. The reason is simple. If the distortion occurs closer to the light source, it doesn't compromise the quality of the final image as much. The first challenge we encounter is resolution. Hubble is undoubtedly the best visible light telescope we have, but its resolution has limits. For example, Pluto, which is in the Kuiper Belt, is well within these limits. Before the New Horizons flyby, the best images we've obtained of Pluto were captured by Hubble, and to be honest, they were quite unsatisfactory. To Hubble, what was once considered a planet is just an enigmatic blur. Considering Hubble's resolution and the distance from the table, the resulting image would look something like, well, I'm assuming the table is under a skylight or outdoors. The big problem, however, is motion. Hubble moves through Earth's orbit at a speed exceeding 7 kilometers per second. This means that, to Hubble, the table is moving at that same speed. Any exposure lasting a reasonable amount of time, even if the resolution were perfect, would result in an image completely blurred in the direction of motion. It's like trying to photograph the ground while driving at high speed.
The combination of these two factors, limited resolution and rapid motion, results in a final image that's less than satisfactory. Could we adjust Hubble to track Earth's surface and thus minimize blur? In fact, Hubble already has the ability to rotate to track targets while orbiting. However, these targets are often very distant astronomical objects, and Hubble's onboard automatic system can only handle targets at a distance at least 10 times the distance of the Moon. When astronomers want to use Hubble to capture images of the Moon, they need to send manual commands to adjust the telescope's position and activate the camera during this maneuver. The result isn't as efficient as one might hope. The images obtained are better than what our eyes can see, but they still don't compare to the quality Hubble is capable of producing. Here's our table, with an image reflecting this degradation. Unfortunately, relative to its size, our table is moving toward the telescope at a much faster speed than the Moon. Interestingly, the table isn't moving as quickly in terms of angle. For Hubble to track Earth's surface, it would need to rotate at less than 1 degree per second, or about 1/10 of a revolution per minute. However, Hubble wasn't designed for this type of tracking. Its maximum rotation speed is only a few degrees per minute, which is comparable to the speed of a clock's minute hand. Even these speeds are fast enough that the vibrations generated by the gyroscopes compromise image quality. Clearly, we would need a more efficient tracking control system. Hubble's rotational moment of inertia is similar to that of a small carousel, which isn't that large in absolute terms. With a custom system, Hubble could be able to track the Earth's surface and capture images that would approach its ideal quality. This means that while Hubble couldn't read your notes, it could watch you roll around in your chair at your desk. But make no mistake, this isn't just a theoretical hypothesis. Much of the technology used in military spy satellites is considered similar to Hubble's. So in a sense, directing a telescope like Hubble at the Earth's surface isn't just a possibility. It's a practice that, in many ways, is already being carried out by the U.S. government. This raises intriguing questions about privacy and surveillance in our modern world. What else could be observed if we had access to this technology? What would be the ethical implications of such a powerful telescope trained on us? Reflecting on all this, we're led to consider not only Hubble's capabilities, but also what it means for our understanding of the universe and ourselves. Human curiosity is insatiable, and the search for answers drives us to explore not only the stars, but also our own planet. So, the next time you look up at the sky, remember that even if Hubble can't capture the image of your desk, it's constantly helping us unravel the mysteries of the cosmos. And who knows, perhaps one day we'll be able to see Earth through the eyes of a telescope that can truly show us every detail, every nuance, and every story our planet has to tell. So, what do you think? Technology is advancing rapidly, and the possibility of observing Earth in such detail may not be so far away. What would you like to see if you had the chance to peer at our planet through a telescope like Hubble? Leave your ideas in the comments, and don't forget to subscribe for more fascinating content about the universe and the science that surrounds us. The journey of exploration is just beginning, and you won't want to miss out.